Good evening, everyone who is here to learn something new, whether you are here to accumulate the tools to help you progress forward in life, or if you are just trying to get through a class, I'm here to help present the information to you. This is Math with Business Applications. I am Amy Fuchsteiner, the instructor. We are working on simple interest and notes. Specifically, simple interest and notes. Come on, there we go. Simple interest and notes. Specifically, we are going to work on using the simple interest formula today. So using simple interest is a part of chapter 10, section 2. This is part 1, solving for principal, rate, and time, because next presentation is part 2. So this is just part 1 of 2 presentations on section 2 from chapter 10. Our goals for today. Oh, hey puppy. Puppy's here at my feet. Our goals for today are to review the simple interest formula, to use that simple interest formula and rearrange it to find the principal, the rate, the time when they are missing, and time in particular. In all of its different iterations, we want you to be able to find the time in years, in months, in weeks, in days, whether those days are ordinary or exact. So the ordinary number of days in a year, sometimes called Banker's Rule, or the exact number of days in a year. So to begin with, remember that interest has 4 different parts. It has the interest, the principal, the rate, which is the percent as a decimal, and the time, which is always in years. In order to complete this, we also showed you the magic triangle. The magic triangle is a graphical tool for helping you to remember the formulas. I'm also going to show you the algebra because I teach math and algebra is where it's at. So, to begin with, interest, which if we're using the magic triangle, we're going to isolate the I. Interest is equal to the principal times the rate times the time. If you are looking at the magic triangle, the beauty of that is that the I, where the green dot is on your screen, is in the numerator, and everything else is in the denominator, the principal, the rate, times time. So principal times rate times time is equal to the interest. That all of this works out. So I is equal to PRT is our formula. Given that formula, we can solve for the principal. Oh, sorry, I'm a little yawny. All right, so we remember that I is equal to PRT, or interest is the principal amount times the rate times the time. In order to isolate the principal, P, we are going to divide both sides by R and T, giving us I over RT is equal to PRT over RT. Now, the beautiful thing on the right is that the R's and the T's cancel, giving us I over RT is equal to P, or P is equal to I over RT. I just flipped the view. No big deal. On your left, the magic triangle. The P for principal, what we're solving for, is underneath the green circle. Notice that I is in your numerator, and in your denominator you have R and T. So it will be I over R times T. This gives us our formula. Principal is equal to interest over rate times time. To try a problem with that, Trixie borrows money at 7% interest for 250 days if the interest she was charged was $2,187.50. Calculate the amount of principal on this one. Such a bad look. Sorry. Whew. Principal is equal to interest over rate times time. I do know that my interest is $2,187.50, and I know my interest rate was 7%, 0.07 as a decimal. My time is 250 days. It doesn't tell me if those days are ordinary or exact. But I remember from the last presentation whoops, there we go, disappeared. That if it doesn't say whether your interest is ordinary or exact, we are going to be using ordinary. The default position is ordinary. Ordinary time and begins with O, and that O shows itself in the 360, the 0 at the end there. That's how I click it in my head. 360 ends in a 0, which looks like an O, which starts ordinary time. So ordinary time is out of 360. So on my calculator, I'm going to be doing 2187.50 divided by 7% or 0.07 times 250 over 360. Now, you'll need to be careful here because if you are typing it all at once into your calculator, you want to make sure to put an extra set of parentheses around that multiplication in the denominator. Alternatively, what you want to do is multiply that denominator first, so 0.07 times 250 over 360. And then you want to keep as many decimal places as you can handle. I usually say 5, sometimes 6. So no matter what that number is, you want to run it out 5, 6 decimal places. If you cut it off too short, if you truncate it just after 1 decimal place or sometimes 2 decimal places, your answer is going to be off. Because the bank is using a computer and running all of that string of decimal places in the number. They're going to let that whole string run. So you want to keep as much of it as you possibly can. When we divide this out, we get $45,000 or $45,000. The principal amount here would be $45,000. Okay, next problem. Going on. Here we are. Maeve had to borrow from the bank to maintain her payroll. She was charged 7.3% exact interest for 60 days. They did say exact. If the interest she was charged was $1,920, calculate the amount of principal for this loan. So principal is interest divided by rate times time. We know that, that was a step too soon, but okay. We know that we have $1,920 in interest. Our rate was 7.3% or 0.073 as a decimal. The days were 60, but they're exact. So that's going to be 60 over 365. That will give us an answer of $160,000. So our principal amount in this case is $160,000. Our next task is to solve for the interest rate. So we're going to start with the same idea. We've got our magic triangle on your left, and we know interest is equal to principal times rate times time, or I is equal to PRT. In order to isolate the R, we're going to divide both sides by P and T. That means we're going to have I over PT is equal to PRT over PT. Again, the P's and the T's will cancel on your right-hand side, giving you I over PT is equal to R, or R is I over P times T. Magic triangle, you can see the clear divisor line above and below. So we've got an I in the numerator, and then we've got a P times T in the denominator. So this is what gives us our formula from the magic triangle. And we can see that the rate is equal to the interest over principal times time. And for our next problem then, we have the ordinary interest method. What is the rate of interest on a loan of $63,000 for 90 days if the interest was $1,299.38? We want to answer to the nearest hundredth of a percent. So we have from the formula R is equal to I over PT. Our interest rate is $1,299.38. Our principal is the amount of the initial loan, which is $63,000. Our time is 90 days, and I know it's out of 360 because this time they said ordinary. Again, the O in ordinary is the 0 on the end of 360. So if I'm cognizant or if I remember about my parentheses, I've got to be careful about those. I either want to include them when I multiply through on my calculator, or I want to figure out what that denominator is first. I will get a 0.082500317. Notice I'm keeping as many decimal places as I can. Now, I need to convert this to the nearest hundredth of a percent. Don't get it confused here. In order to figure out the hundredth of a percent, I first have to calculate what this would be as a percent. To do that, I would multiply by 100, or if you'd rather, I'm just going to move the decimal point over 2 places. That's going to give me 8.2500317%. I need the hundredth of a percent. And in the hundredth place, once it's a percent, I have a 5. To the right of that is a 0, which means it's just going to stay 8.25%. Second example. Kyle took out a simple interest loan for $84,000 to make a partial payment and save himself some cash. So he's going to borrow money to pay off a different loan that's charging him higher interest. His terms were exact interest, 25 days, and his repayment was $84,198.33. Determine his interest rate to the nearest tenth of a percent this time. All right. So we know from the formula that rate is equal to interest over P times T. I know the principal, it's $84,000. I know the time, it's 25 days. I even know that it's exact. So it's going to be 25 out of 365. I'm on top of things. What about the interest? Nowhere in this problem does it say interest. I've got the $84,000, that's the principal. And I've got the repayment. That's $84,198.33. So they paid more than they borrowed. That's the interest. The additional repayment is the interest. So if I need to calculate the interest and I know the maturity value or the repayment amount of $84,198.33, I can subtract the initial principal of $84,000 to get me the interest of $198.33. Now, that's an extra step to the problem, but it's absolutely feasible. So now I have interest rate is $198.33 over $84,000 times 25 over 365. Again, there's multiple things in that denominator, so I want to make sure that I'm using parentheses to isolate it. And when I do that, I get 0.034471643. I need this percent as a decimal. Or I need it to the nearest tenth place. Sorry, tenth of a percent. So first, I'm going to convert this to a percent. To do that, I'll move my decimal point 2 places to the right, or multiply by 100. Either works. And I get 3.44171643%. In the tenths place, I have a 4. To the right of that 4, I have another 4, which means I need to round down, and I have 3.4%. We're moving on to time, because time keeps moving on. That's a pretty bad joke. All right, so again, magic triangle, I equal PRT, gives us our formula. We're going to start with I is equal to principal times rate times time. We're going to isolate the time. Green circle on the time. In order to isolate time, I need to divide both sides of this equation by P and R. So I over PR is equal to PRT over PR. On the right-hand side, the P and R cancel, giving us I over PR is T. Flipping that around, I get T is I over PR. Now, on the magic triangle, note again the top and bottom. Straight line, I in the top, and what's left in the denominator is P and R. Multiplied together, I get P times R. This is the same as the formula. T is equal to I over PR. It's just a trick. It's not really algebra, but some of you may find it really helpful, so use it. All right? Now, we do want you to keep in mind that as you do these problems and you solve for time, it will be in years when you solve for it. Your initial answer will be in years because the formula I equals PRT calculates time in years. That's why we're always dividing by 360 or 365. So as we do these problems, you're going to have to convert your answer into months, weeks, or days. It depends. So in this very first example, we're going to practice that with you. What is the time period for a loan of $500,000 at 6% interest rate if the interest paid is $17,500? We know time is interest over principal times rate. We know our interest is $17,500. We know our principal is $500,000. We know our rate is 6%. As a decimal, that's 0.06. So we're going to do 17,500 divided by 500,000, 500,000 times 0.06. That gives us, oh, watch those parentheses. Watch them. That gives us 0.058333333. That's a part of a year. That's 0.0583 of a year. Does that make sense to you? I mean, if we really wanted to talk about it, we could say, okay, so it's a little bit more than half a year, right? But in terms of looking at that to make like common sense, if I can say that phrase, it's not easily understood, right? So what we're going to do with this particular answer is we are going to use it as an example to convert to different time frames. I had said that one of the goals of this class is that you're able to convert to days, whether they be ordinary or exact, months, and weeks, along with years. So we're going to start with the 0.583 repeating, and we're going to convert it firstly to months. We're going to multiply by 12. Because we know that this is a portion of a year. And if we want that year counted in months, there are 12 months in a year. So if I take the 0.583 repeating and multiply it by 12, because there are 12 months in a year, I will get 7, or 7 months. So 0.583333 of a year is 7 months. This is a nice answer for a couple of reasons. First of all, it's a solid number, no decimals. 7 months, I get 7 months. 7 months makes sense. 0.583 of a year, I don't even want to think about what that is. Don't want to think about it. But 7 months, perfect sense. I get 7 months. If we had to convert it to weeks, do you know how many weeks are in a year? Yep, 52. So I'm going to take 0.583 repeating and multiply that by 52 because there are 52 weeks in a year. And when I do that, I get 30.33 or 30 1/3. That means that 0.583333 of a year is 30 1/3 weeks. This is a valid answer, but I don't like it. Nobody thinks about 1/3 of a week. Who thinks about 1/3 of a week? 30 weeks makes sense. 31 weeks makes sense. But 30 1/3? Doesn't make sense. We don't do weeks very often, but there is one skill at the very end of the chapter that I might throw in for some extra credit. Yeah, I'll probably throw it in for some extra credit. And that one uses weeks. So it's a good thing that I do this. All right. So now we've got to look at days. And in order to convert it to days, we need to talk about whether it's ordinary or exact. So if we're doing 0.58333 of a year and we're doing ordinary, we know that there are 360 days in an ordinary year. So ordinary days in a year is 360. If I multiply this by 360, I get 210 or 210 days. Similarly, if I want to do the exact interest, so there are 365 exact days in a year. Well, it's 365 and a quarter, but I don't want to go there. 365 days in an exact year, I get 213 days. So as you're doing these problems, be very careful about the time. You're going to have to pay attention to it because it does make a difference. All 4 of these answers, well, 5 really, if I count the 0.583 of a year. So all of these 5 answers are the equivalent time frame. They're just stated in different units, different measurements, right? Let's find the time. All right, so what is the time period for a loan of $7,200 at 12% ordinary interest rate if the interest paid is $300? We know time is equal to interest over principal times rate. What's going on there? Here we go. All right, so my interest is 300. I'm dividing that by 7,200 times 0.12, or the principal of 7,200 times the rate of 12% as a decimal, so 0.12. I'm going to watch my parentheses because they will make a difference. And I get 0.347 with a repeating 2. Now, this is 0.3472 repeating of a year. So it's a little bit more than a third of a year. It's less than a half of a year. But I need it to be in ordinary days. And since I need it to be in ordinary days, I'm going to multiply this by 360. So 0.347 with repeating 2's times 360 is 125. 125 what? Ordinary time is days, so 125 days. Another example. What is the time period for a loan of $240,000 at 4% exact interest rate if the interest paid was $6,400? So again, time is interest over principal times rate. I know my interest is $6,400. I know my principal is $240,000. My interest rate is 4% or 0.04. Putting that into the formula, I have 64,000 over, and I want to make sure that my calculator calculates that multiplication first, or I'm going to do it out, but 240,000 times 0.04. And if I calculate that, I should get a 0.6 repeating. 0.6666666666666. This is a portion of a year. I need to know what they want the time in. And since they've requested exact interest rate, or since they've stated exact interest rate in the problem, I want to multiply by 365. So I'm going to take a 0.6 repeating times 365 to get 243.3 repeating days. Now, this is another one of the quirks of days. When you are repaying something, the bank cannot tell you what time you need to have the payment in by. I mean, they can give a generic time, like everybody's payment needs to be in by 10, but it needs to be the same for everyone. So when you get a portion of a day, when you have like a hanging decimal at the end of a day here, you always just make it the next full day. So in other words, you would always round up. Days will always round up. You cannot short somebody a day to pay. So if this was 243.1, we would still round it up to 244. If this was 243.027, we would still round it up to 244. If there is any hanging decimal at the end of this, it always gets rounded up to the next number of days. And that happens if it's ordinary, and it happens if it's exact. Either format. All right? Okay. Nick is going to take on a loan of $12,000 at 8.7% interest. If his maturity value is $13,218, how many months was this loan? Again, we know that time is interest divided by principal times rate. I have the principal at $12,000. I've got the rate at 8.7%. Interest, they did not tell me. But they did give me maturity value. And I know the principal. So I can use that interest is maturity value minus principal, or $13,218 repaid, right? Minus the $12,000 that that Nick initially took out, gives me $1,218 in interest. So that means my formula substitutions would be the 12,018 divided by 12,000 times 0.87. And I want to make sure to do the 12,000 times 0.87 together. So I'm either going to put that in parentheses, or I'm going to calculate just that piece and then plug that number back in. When I do that division, I get 1.1666666 repeating. It's a little bit abnormal because it is over 1, and for the most part, you should get answers that are, I would say, less than 1, but every once in a while, 1 will sneak in. This is in years, so this is 1.16 years, so it's a little bit more than 1 year. The answer, however, should be in months. So since there are 12 months in a year, I'm going to go ahead and take this number and multiply it by 12. And when I do that, I get a full-on answer of 14. So I trust the answer in part because it worked out to be a nice, solid number. It's just one of the things we do. All right. That was our last example for this particular section. So as we review things, the question is, do you feel like you could review the simple interest formula? We set out to do that. Have we done it? Can you use that simple interest formula to find principal, rate, and time in all of its different iterations, including years, months, weeks, days of both the ordinary and exact persuasion? You do? Great. All right. If you're ready for additional practice, you will find it in your e-textbook in Chapter 10, Section 2. There are review exercises. I would recommend doing 1 through 37. It's not all of the problems, and I think I've avoided the part 2 in this particular review section. That extra practice, if you have a physical copy of the textbook, is on pages 314 to 321 in the text. The graded assignment that you will find for this section is on WebAssign. It is Chapter 10, Section 2, and it is titled Chapter 10, Section 2, No PPC. PPC is partial payment, which is what we'll be doing in the next section. Unfortunately, there is no surprise puppy this time. He is sound asleep at my feet. As always, if you have any questions, please don't hesitate to contact your instructor. That's me, Amy, your embedded support personnel, the Math Center at Western, or any other tutor you may have available to you. Everyone is here to help. We all want to see you succeed. Thank you.